All right, everyone, welcome back to Speech Understanding. Let me go ahead and start lecture 4 today, and I'm going to start with a Python notebook today rather than presenting from PowerPoint slides. We'll start directly from a Python notebook. So this is the Intro to Speech Understanding, the course distribution, from which you should be able to download software using Git Fetch. So let me go ahead and do that. Let me open up a terminal. And let's CD to KCGI and CD to intro speech understanding. And then if we list, we see that we currently only have lecture 4, but if we do git fetch from the release and then git merge release main, and let's add a comment, and let's add allow unrelated histories. Now when we list, we now have lecture 4. And if you look at the lecture slides today, it says you should be able to start the notebook by doing something like changing directory into lecture 4. If you're in Windows, you might have to do CHDIR rather than CD, but it's something like CD lecture 4. And then you should be able to type something like Jupyter Notebook and have it automatically start. Let me increase the size so that you can see this, right? We did git fetch release, and then we did um, git merge in order to get the release, git merge release main, allow unrelated histories. And then we change directory into lecture 4, and then we type Jupyter in order to start Jupyter. This works if you have Anaconda installed, and it will also work if you have Jupyter installed in any other package. Jupyter becomes available to you on the command line. You can start it from the command line, and that will start open your web browser and start the web browser in the way shown here. Now I'm looking at the files on my own computer, so I can open up Lecture 4 Notebook and begin the course. We can also, by the way, go and check to make sure whether I uploaded the done version of Homework 4 or the not finished version of Homework 4. Looks like it's the not finished version. It specifies birthday is January 1st, list of names is no list of names. So that means that by the end of today's lecture, we should try to finish Homework 4. What I want to talk about today are two new data types. Remember last class we talked about lists, and lists are very much the main data type in Python. In this class, I want to talk about the two other main container types, dictionaries and tuples. Both of them are similar to lists, but not quite the same. A tuple is almost identical to a list, except that it's not writable, whereas a dictionary is writable, but a dictionary has an index that can be anything other than an integer. So if I create the dictionary 0, this is the value number 0, and then some key 35, and then print the dictionary, it will be something like 0, this is the value 35. So let's add some things here. Dict1 is, and then it prints the dictionary, and then I'll print a new line after that. And then let's print its first element is. Oh, we don't even have the concept of a first element. Because we have one element that's indexed by the number 0 and another element that's indexed by the string some key. And this is what really makes a dictionary different from a list from a list is that whereas a list is always indexed by integers, like the integer 0, right? But a dictionary can be indexed by anything. You can index it by a string or by an integer or by a floating point number. Let me even add a floating point number as the index. Let's say that 4.12 is a key, and 4.12 will point to oh the a string. Let me call it a string. All right, and that should show up. And let me go ahead and print that element separately. We'll print that as element dict1 of 4.12 is, and what it is. Let me even, we can even take a Boolean. We can even say that true maps to something. Let's say true maps to 0 and false maps to 1. So I'll say print element dict1 of true and show what that is. Element dict1 of true is, and then we'll look up what dict1 of true is. Now let's print all of these things and see what happens. Oh, unterminated string. I need to terminate the string. There we go. And here again. And here again, I need to terminate the new line. I think that finishes it. Let's try again. Right. Dictionary maps 0 to the number 1. It maps the string some key to the number 35. It maps the floating point number 4.12 to a string called a string. And it maps the Boolean value true to a value 0. Something that's interesting here is we can change any one of these values. So for example, let's say that I want to change dict1 of true. And let me then change it. Dict1 of true. I'm going to say now, rather than being the number 0, now I'm going to say dict1 of true is false. And now let's print it out. Dict1 of true is, and then we'll print out the value dict1 of true, and then print a new line. Let's run this again, and we see that dict1 of true is 0 at first, but then after I change it, dict1 of true becomes false. So any particular key can only look up one value inside a dictionary. The value that it looks up is for any particular key, there's only one value. You can't have a key that maps to multiple values unless the key actually maps to an array, a list. Let's make it map to a list. Let me add a new cell underneath. Let's say that the dictionary A will be a dictionary that maps key 1 to the list 4, 5, 6, 7, and then key 2 will map to the number 5. And let's say A of key 1 is, and then we'll print A of key 1. We'd better make that a string, hadn't we? We'll make that a string by putting quotation marks on either end, and then print a new line. Now we see that A of key 1 is 4, 5, 6, 7. So I can store an entire list. So for example, I could say A of key 1 of 0 and tell what is A of key 1 of 0. If you had to guess, what would be A of key 1 of 0? It should be the very first element in this list, which is the number 4. A of key 1 of 0 is 4. A of key 1 of 1 will be the second element in that list, which will be the number 5. A of key 1 of 2 will be the third element in that list, which is the number 6, and so on. And so you see we can store these sort of hierarchically. We can store a dictionary which maps to a list, and the list can look up individual elements. Just like there are methods for a list, there are also methods for a dictionary. So one of the interesting elements is enumerate. We can use enumerate, which returns rather than one element of the dictionary at a time. Oh, I haven't shown you actually that we can go through the elements of a dictionary. Let me add that. For k in dict1, print k, and let's just see what that does. That lists all of the keys in dict1. The keys are 0, some key, 4.12, and true. So you can see that as we iterate through the dictionary, what we're actually iterating through are the keys in the dictionary. And you might reasonably ask, well, how do I get back the values? One way you can get back the values is by printing, by just looking it up. So I can print K and then dict1 of K. And what that will do is it'll print 0, which is the key, and then 1, which is the value being stored. Some key, which is the key, and 35, which is the value being stored. 4.12, which is the key, and a string, which is the value being stored. But other ways you can get them is by enumerating. We can enumerate the keys. So I can take the keys of the dictionary and enumerate them. Key number 0 is 0. Key number 1 is some key. Key number 2 is 4.12. Key number 3 is true. Enumerate just lists them off along with their numbers. So you see that here, K is the key and N is the number, and they're returned by enumerate in that order, N first and then K. The ordering of the keys in a dictionary is not guaranteed. As your dictionary gets larger, it will get copied to a new location in your computer's memory. And when it gets copied to a new location in your computer's memory, it might get lost. Notice also that dict1 keys does exactly the same as dict1. It just returns the keys in the dictionary. So if I just say for nk and enumerate the dictionary, I still get the keys. If I want to get the values, I can either type and its value is, and then dict1 of k. That's one way of getting the value. And its value is 1, 35, a string, and false. Or I can use the function values, which returns the values one after another. So in dict1, the values are 1, 35, a string, and false. And you can see that this method called values returns a list of the values in the dictionary, one at a time. It's not a list, actually. It's a values object. Let's see what it returns. Let's see how it gets printed out. If I ask it what is printed out when I return dict1 values, it's actually an object of type dict values, which is just basically a listing of the values associated with every key in the dictionary. And then you might say, suppose that you might want the values together with their keys. The way that you can do that is by using the dot items function. And the dot items returns pairs of items. So let's run this. We have the pairs of items 0, which is the key that maps to the value 1. Some key is the key that maps to the value 35. 4.12 is the key that maps to the value a string. And true is the key that maps to the value false. So this dictionary that I've created up here, this dictionary that I've created, has 4 different keys, each of which is associated with a value, and you can see that we've returned them as pairs. These pairs are called tuples. These are like lists, but they're lists that can't be changed. So we could list, for example, the key is, and we can take k of 0. Let me call this, instead of k, let me call it item, because it's an item. And the item is actually a pair that includes the key and the value. Item 1 is the value. So you can see the key is 0, the value is 1. Let me put indent here so it shows us the structure. Item number 0 is 0, 1. The key is 0, the value is 1. Item number 1 is some key, comma 35. The key is some key, the value is 35. Item number 2 is 4.12 and a string. The key is 4.12, the value is a string. Item number 3 is true, comma false. The key is true and the value is false. And so you see that the dot items function of a dictionary returns all of the elements of that dictionary one at a time, all of the key value pairs. We can also find other methods for dictionary. So let's look up Python dict methods, dictionary methods, I guess. Um, Here's more on lists, and let's go down to find out more about dictionaries. Under dictionaries, the tutorial tells us that we can look up a particular item by looking up the key. It also gets the value of that particular item. This is similar to just looking up the item, except that if the item doesn't exist, you'll get a key error. Where if you try the get function, it will return instead none. Rather than returning a key error, it will return none. We can also list all of the keys, and we can also sort all of the keys in the dictionary. We can also ask, is a particular key in the dictionary? And it will tell us true if the key is in the dictionary, or false if the key is not in the dictionary. So you can ask if a particular item is in the dictionary, then do something, and if not, then do something else. Right? You can also use list comprehension to create a dictionary. You can, for example, map from x to x squared. Let's try that. That looks kind of interesting. Let's create a new dictionary and let's call it squares. And let's say that squares is the mapping from x to x squared, or x in the array, let's say, range from 0 to 5 with a step size of 1. And we see that squares is the dictionary that maps 0 to 0 squared. It maps 1 to 1 squared. It maps 2 to 2 squared, which is 4. Maps 3 to 3 squared, and it maps 4 to 4 squared. So we can use list comprehension. In the case of dictionaries, you could call it dictionary comprehension, where it just runs through all of the items in this tuple and generates a pair, a key and a value for each of those items. We can also use the dict function to create a dictionary by specifying the key and the value for each of them. Looping techniques include the dot items that I mentioned, the enumerate that I mentioned. We can also zip together a list of questions and a list of answers. We can also reverse a list. We can also sort the list. We can also sort the items in a set. And we can do things with the math library. Like, for example, we can check whether a particular number is a number or not. All right, those are dictionaries. Dictionaries are really useful, and in other languages like Perl, in a language that's called Perl, a dictionary is the fundamental data type. In Python, I would say that the list is the fundamental data type. In Python, a dictionary is not quite as useful as a list. Dictionaries are useful for some things that lists can't be used for, but really the fundamental data type is the list. Which is especially evident if you look at the third key container data type, the tuple. A tuple is exactly like a list, except that where a list starts with a square bracket, a tuple starts with parentheses. Otherwise, it's almost exactly the same. The only difference between a list and a tuple is that a list can be changed. So here I'm going to take the fourth element of this list, list 3, and I'm going to replace it with the string great list. With a list, that can be done, but with a tuple, that can't be done. So syntactically, the difference is that a tuple uses curved parentheses rather than square brackets. And semantically, the difference is that a tuple cannot be written, whereas a list can be written. So you see we have list 1 is this is a list 0, 1, 2, true, false. Tuple 1 is this is a tuple 0, 1, 2, true, false. Now I tried to modify list 1 so its fourth element is great list, and now list 1 is this is a great list 0, 1, 2, true, false. Now I tried to modify tuple 1 so its fourth element is great tuple, and it generates an error. It says type error, tuple does not support item assignment. And so The only real difference, the only difference between tuples and lists is that you can't change a tuple once you've created it. Once you've created it, it's there for good. You can't change it ever. And you might say, that's a really stupid difference. Why would anybody create a data type that simply can't be changed? It seems like a really stupid thing to do. The reason is that if it can't be changed, then it can be used as the key for a dictionary. So if I try to create a dictionary called birthdays, I'll create an empty dictionary, and then I'll try to say that January 10th, the person who has a birthday on January 10th, those people are Fred and Anna. So I tried to do that, and I discovered that I can't use a list as the key in a dictionary. And the reason is because lists can be changed at any time. So if I try to use the list 1, comma 10 as the key in a dictionary, then I might go back and change the content of that list. And so that doesn't make sense to use a key into a dictionary when the key itself is some data type that might be changed later. But a tuple can be used as a key because once you create a tuple, it can never ever be changed ever again. And so I can create a dictionary birthdays that maps from January 10th to the string, the list Fred and Anna, in order to specify that Fred and Anna are two people who have birthdays on January 10th. Other than that, tuples act just exactly like lists. They can be added, multiplied just like lists. So just like I can take a list and add two lists together, I can also add two tuples together. We can see that when I add hello world plus ABC, I get the list hello world ABC. If I add the tuple hello world plus the tuple ABC, I get the tuple hello world ABC. If I take the list and multiply it by 4, I get the list ABC, 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 ABC. If I take the tuple and multiply it by 2, I get the tuple ABC, ABC. So lists and tuples behave almost exactly the same way. The only difference is that you can't write to a tuple. Here's the tutorial online for how to deal with tuples. You can see everything I've just said, that a tuple, you don't even have to specify the parentheses. You can just have a comma separated sequence of elements, but it's more useful to put the parentheses because then it's obvious what you're talking about. So here we have V is the tuple of a list 1, 2, 3 and a list 3, 2, 1. So tuples are basically, here's an empty tuple with 0 elements in it. The length of the empty tuple is 0. The length of the singleton tuple is 1. And the singleton tuple is the element hello, followed by nothing. We can also unpack the return elements from a function as a tuple. So I can take that tuple t and unpack it into xyz. And this is especially useful when we return from a function, as we're going to do in the homework. So let's import the homework and see what it has. Homework 4 has just one function that you need to create. This is the function next birthday, given a date and given a set of birthdays. The date will be a tuple of 2 integers specifying a month and a day. For example, January 10th would be 1, comma 10, or June 26th would be 6, comma 26. And the idea is that the birthdays should be a dictionary that maps from a date in the form of a tuple to a list of all of the people who have birthdays on that date. And the goal of this function is to search through the birthdays list for the next birthday that follows the given date, right? So if the birthdays dictionary has all of these elements in it, and if we ask what's the next birthday after June 6th, right? The next birthday after June 6th should be September 19th. And so it should return that the next birthday is 919, and the list of names should be Seth and Fred. If we run this code right now, of course, it will return the wrong value. The next birthday after June 6th is 1-1, it says, which is false. The people with birthdays on that day, it returns no elements at all. And so in order to make this work, we need to edit the homework. So let's go and try to edit the homework. We need to loop through the birthdays, and somehow for each of we need to basically start at the current date, So let's say month and day is equal to the date. We'll split it up, and then we'll basically while um, while month and day is we're going to need to check to see whether month and day is in birthdays. So let's say while month and day is not in birthdays, because month, right? If it's in birthdays, then we just want to return that right away. So we'll return the birthday will be the birthday that we're going to return will be um, month comma day. So this here, what we want to do is we want to increment month and day until we find it in birthdays. And then once we find it, then we just return the birthday as month comma day, and the list of names should be the value of birthdays at that particular birthday, right? So we just want to kind of increment the month and the day until we finally get to a value that's actually in birthdays. And how do we do that? Well, first of all, we'd better add day is equal to day plus one. And then we better check to see whether it's past the end of the month. And fortunately, we don't have to worry about short months, because if we go on and we say February 29th, February 30th, February 31st, those won't matter because those simply don't exist in birthdays. So we can just check and see if day is greater than or equal to 32, then that means that we're past the end of the month. So we'd better set day is equal to 1 in that case, and month is equal to month plus 1. And if month is set equal to month plus 1, we'd better check and see if month is greater than or equal to 13, right? If month is greater than or equal to 13, then in fact we'd better set month equal to 1. Right, so here's the logic. We're going to just set day equal to day plus 1. And then if the day is too large, we'll set the day equal to 1, and we'll set the month equal to the month plus 1. If the month is greater than or equal to 13, we'll set the month equal to 1. And we'll keep doing that. Let's check for an extra value. Let's say, first of all, if length of birthdays is equal to 0, then in that case, we'd better raise an error. I'm going to raise what's called a runtime error, which will say birthdays cannot be empty. This will never happen. This is good programming practice, and you don't need to do this step in your function. But this is just if somebody tries to give you an empty dictionary as the birthday, then this loop would run forever. And so in order to prevent this loop from running forever, we'll just check first to make sure that there's at least one birthday. If let's also check and see if length birthday is equal to 1. No, let's not check that. Let's just do this part. All right, so now what it will do is it will just increment through the month and the day until it finds one that's in the birthday. And then when it finds one that's in the birthdays dictionary, then it will set the birthday equal to that month and day and return the corresponding list of names. Let me save this Python file and let's check to see if that gives us the expected result. I got a problem. Homework for next birthday, return birthday and list of names. Um, I did import lib reload homework 4. Let me just save that to make sure. It seems like it's not reloading it. Let me see if I'm in the right directory. Homework 4 does have the values that I told it to have. Let me just reload it here. Import lib reload homework 4. Um, Birthday list of names equals homework for next birthday birthdays. Well, it seems like I have some syntax error, but it's not printing it. It's not telling me very well what the syntax error might be. So let's say that month is date of 0. Let's eliminate this part. While month and day are not in birthdays, increment them until we find them, and then set birthday equals to month, comma, day, and list of names equals birthdays, birthday, and then let's return birthday, comma, list of names. There we go. The next birthday after June 6th is 9/19, and the people with birthdays on that date are Seth and Fred. Let me try checking to see what the next birthday after January 2nd is. That should be January 10th, and the people should be Anna and Bob. There we go, January 10th. I'll go ahead and set this as a variable so that it shows up correctly in my printout. There we go. So the next birthday after 1/2 is 1/10. Let's try the date 1/30. Let's see what the next birthday after January 30th is. It looks like the next birthday is 2/14, and the person with a birthday on that date is Valentine. Of course, St. Valentine has a birthday on January 30th. Let's see about February 3rd. No, February 16th. Let's see who's next after February 16th. The next birthday after February 16th is March 3rd, and Mary has a birthday on that date. Let's try December 16th. The next birthday after December 16th is January 10th, and the people with birthdays on that date are Anna and Bob. And so our function now has we have this code that will increment through all of the days and months of the year, looping back around to the beginning of the year if it overshoots, and then return that birthday and return the list of names of people who have that birthday. Let's just check to make sure that the grading code works. If I run the grading code, it said that I got score of 100%. So now I ready to upload to GitHub. Let me try GitHub Desktop. Let's go ahead and push homework 4. We'll commit it to the main locally, and then we'll push it to the origin. And then let me check online to make sure that my GitHub account has it online. github.com. If I go switch my accounts from my teacher account to my student account, then I should be able to find new student, uh, lecture 4, homework 4, and I can see that in fact it does have all of the changes that I wrote. So now I can copy this and then go to Canvas. And if you open homework 4 in Canvas, you should be able to just enter the URL for your copy of homework 4, and then I can give you points for that submission. That's all we have for today's assignment. So let me go ahead and turn off the recording first of all.